All right, so Leona and Kian, I think, is recording the class. Leona is recording the class. So she can probably provide a link. When she's finished, she can provide a link that you guys can rewatch it. All right. Okay, awesome. All right, good. So now, let us get into something more important, right? Apart from the whole language, because we're not going to fully get it yet, you know. But let's get into something more important. We're going to look at the different types of fractions that you're going to encounter, right? And there are two types of fractions which I'm going to make another assumption that you guys know what these two fractions are. All right. So here it is. We have subheading, guys, is types of fractions. Just write that for me, guys. Okay, you know my finger now to work right here. So all right. So types of fractions. That's the heading, guys. There are two types of fractions. There are two types of fractions. One, proper fraction. That's P-R-O-P-E-R, proper fraction. And then we have number two, improper fraction. All right. Now, a few of you might be wondering, then, sir, what happened to mixed fraction? Improper fraction and mixed fraction is the same. They're both the same. All right. And the reason why they're the same is that mixed fraction is just another way of expressing an improper fraction, which you're going to see in a second. So mixed fraction and improper fraction are one in the same. They're just expressed differently. Okay? Now, what exactly is a proper fraction? And how am I going to be able to recognize it when I see it numerically written down on paper? So when you come to a proper fraction, guys, right? What you're saying is that with a proper fraction, n is going to be less than d. What we mean by that? We mean that the numerator has to always be a value that is less than the denominator. For example, an example of a proper fraction, let me just draw an arrow coming down here. So an example of a proper fraction would be like something like, say I pick 2, I go pick one number where higher than 2. Doesn't matter, just higher than 2, 3. That's an example of a proper fraction. Let me pick another number, let's pick 4. And we pick a number where higher than 4, 7. That's an example of a proper fraction. Another example would be like me pick a big number like 11. And now I'm going to pick one number with bigger than 11, 17. That's a proper fraction. Now, what you don't want to do is you don't want to pick a number like, say, 4 and then pick 8. Because 4 over 8 can chop down to 1 over 2. So when you're coming up with your examples on your own, if so desire, when you're coming up with your examples, try to pick a number that cannot go into the bottom number. All right, Mr. Them can't go into each other. Okay? So let's say I pick a number like 9. I don't want to pick 15. Because if I pick 15, something can go in a 9 and in a 15, which I go reduce my fraction to say here 3 over 5. So as opposed to saying 9 over 15, we could have just say 3 over 5. So you want to choose numbers that are not divisible by each other. The bottom cannot go into the top, and the top cannot go into the bottom, and there's nothing that can go into the top and the bottom. Do we follow?
Yes, sir.
Yes, sir.
So those are examples of what we call proper fraction. All right? Those are the examples. 2/3, 4/7, 11, 17. And you can go all day, all night and make these up. All right? You can't miss them. Let's just squeeze another one in here. Let's call it 8/9. All right, boom. Now, when it comes to improper fraction now, it's just the opposite of proper. So with an improper fraction, now let's put an arrow down here, guys. Down here. All right, so watch the arrow with a point from. So improper fraction now, we're looking at the fact that n is actually greater than d. So the number that is at the top, the number that you choose to put at the top, it has to be bigger than what you have at the bottom. For example, I could choose any random number now, any number. Let's say me choose 13. All me have to do to create the improper fraction, we just choose a number with less than 13. We can choose 9. So 13 over 9 is what is known as a improper fraction. We can pick another number. We can pick something like 20. I'm going to pick one number with less than 20. We can pick 17. That's an example of an improper fraction. One more example, squeeze it in, semi-pick 7. We will pick one number with less than 7. 3. 7 over 3. That's an improper fraction. All right? Do we guys get it?
Yes, sir.
Yes, sir.
So a proper fraction basically is what we refer to as being a reduced fraction. Meaning say it can't go no further. Any further than where they right now would be you turning it into a decimal. But with the improper fraction now, we can rewrite it in different forms. We can leave it as it is in its improper state, or we can rewrite it into a mixed fraction, which is what we are going to next. All right? So we're going to this next now. We're going to be looking at fraction conversion. All right? This is very, very, like everything in math, some things are just more important than some. And when it comes to fractions, the two things that I'm going to show you on screen now are crucial when it comes to solving any and every fraction problem. So head up for me, guys, as a subheading, fraction conversion. Now, there's two conversions that you'll be required to do automatically. You're not going to get any instruction to say, hey, Latisha, convert this mixed fraction to improper. Or Kayan, convert this mixed fraction to improper. We're not going to instruct you to do that. It's just going to be something that you see and you just know say it has to be done. In fact, you can't solve the problem without doing it. So the first thing that I want to show you now is, in fact, the first thing that you'll be required to do when you do advanced questions. And that is, in fact, converting
Stacey got kicked out.
Pardon me?
Stacey got kicked out. She's asking to be let back in.
Okay. All right, so the first thing that we're going to be required to do here is to know how to convert a mixed number or a mixed fraction to an improper. So what we're looking at now is mixed to improper. Now,
Sir,
I never show you what I'm. Pardon me?
I got bumped off, so I missed everything with improper fraction. Sorry about that.
Oh no, we were only saying that an improper fraction, sorry, a proper fraction is where the top number is smaller than the bottom number. Let's say
No, I got
2
that one. I got that one. But when you reach the improper, that's when I got one.
The improper is just the opposite then.
Okay.
Improper is where the top number now is larger than the bottom number. 3 over 2 example. So that's the only thing that we did before you got kicked out. After you got kicked out, pardon me. All right, so we have mixed to improper. This is where we're at now. All right. Now, I didn't even realize that I didn't even show you an example of what a mixed fraction looks like. But I'm going to make the assumption that you guys already know what a mixed number is. So a mixed number, you can write, I'm not sure if you guys want to write it down, right? But a mixed number is basically a whole number and a proper fraction joined together. So a mixed number would be something more like, say, you have 1 and you have a proper fraction beside it, a half. Or you have something like 2 and you have another proper fraction like 2/3. Or you have something like 3 and then you have a proper fraction like 4/5. So a mixed number or a mixed fraction is basically a quantity that consists of a whole number, and right beside the whole number you have a proper fraction attached to it. I'm going to make the assumption that you guys have seen this before. All right? Doubt if anybody is here that has never seen this before, but if you haven't seen it before, then that's what a mixed number is like. Stacey, you still in the class?
Yes, sir.
Okay, can we just saw a message come from you a while ago? Or it must be a different Stacey.
So it was when I was out, when I got bumped out.
Okay, got you. All right, boom. So now we're learning how to convert from the mix to the improper. But why? Why this man is telling me to convert this thing that I'm looking at to an improper? Why? Because to solve a fraction problem, we need to get it into a different form. We need to make it look like the top number bigger than the bottom. So how do we do this then? Let's take, for example, 1.5, right? We're going to take the number at the bottom, which is the denominator, right? Let me just change my ink here for a second. Ballpoint pen, okay. Boom. So we're going to take the bottom number, which is 2, right? And we're going to therefore multiply it by the number at the side, which is 1. And when we done do that, we're going to add the top number to the result and put it back over 2. So basically what we're saying then is that we're going to take 2 and multiply it by 1, and then we're going to add 1 to the result. So 2 times 1 is 2, plus 1 is 3/2. All right? Example number 2, we have 2 and 2/3, 2 and 2/3. We know some 3 don't look so wonderful, but you get the idea. 2 and 2/3. We're going to take the 3 and we're going to multiply it by the 2 at the side here. So 3 times 2 is 6. Then we're going to add 2 to the result. So that's going to be 8. And that's going to be 8/3. Hold on, guys. I take me small, guys. All right, last example. 3 and 4/5. We're going to take the 5 and we're going to multiply it by the 3. And then we're going to add 4 to the result. So 5 times 3 is 15. 15 plus 4 is going to be 19/5. Everybody good with that?
Yes, sir.
Everybody's okay?
Yes, sir.
All right. So when do we normally do this? I think that students might have the question. I mean, eventually going to get it without even me telling you this. But when do we normally do this? We normally have to do this at the very beginning of the math problem. So when you get a math problem to do that is involving fractions, the moment you see one mixed fraction, you have to convert that mixed fraction to an improper fraction. It's mandatory. You have to do it, or you can't move any further. All right? So that's when you normally do it at the very beginning of the question. Now, just like a vehicle, if you can drive a vehicle forward you must be able to reverse the vehicle. Anything will go up must come down, you know. And if something can be pushed to the left, then you can push it back to the right. And like the car, if something can go forward, then you must be able to put it backward. So maths is the same thing. If we are able to convert from a mixed to an improper effectively, then if you put it to one state, you must be able to put it back to the state it was coming from. So then we're going to look at the fact that we need to convert from an improper back to a mix. Again, the question is, or the question that might be lurking is, when and why? When we do it is at the very end of the question. When you're going to say, Mr. Pierre, this is my final answer. So once you're going to say, this is my final answer, this is the answer that I want to give you the mark for, that's when usually you have to convert your improper back to a mix. And why do we have to do this? Because when you're giving your answer must be given in its lowest form, in its lowest term. And an improper fraction, like for example, 3 over 2, 3 over 2 is not the lowest form because 2 can go in a 3. Yes, it'll go left for a remainder, but 3 over 2 as it is not the lowest form. The lowest form would have been something like 2 over 3, or 3 over 8, or 5 over 19. It can't go no further, but once it flips upside down, then once you have something like 19 over 5, you have to write it back as a mixed fraction to get the full marks. All right? So how do we actually do this? Let's pick up some random examples then. Let's look at something very easy then. Let's look at something like 9 over 4. Or let's say we have 8 over 3. Or let's say that we have something large then like 24. Let's say we have something like 24 over 7. Right? Not so large, but you can go on. So the idea here is for 9 over 4, you want to ask yourself, how much group of 4 can you get from 9? Or as we say in Jamaica, how much time 4 can go into 9? You're going to write down the amount of times you think it can go into 9. Then obviously we know so there's always going to be some sort of remainder, whether it be 1, 2, 3, 4, 5, or infinitely many numbers. 4 goes into 9 2 times. So assuming that you guys know your timetable to an extent, then the remainder is going to be 1, and then you're going to put it back over 4. And that is how you convert from an improper back to a mix. Everybody's with me?
Yes, sir. Yes, sir.
8 over 3. How many groups of 3 can you get from 8? We can count again. 3 plus 3 is 6. So that sounds like you go about 2 times. But there's going to be a slight remainder of about what? 2. And we're going to put that back over 3.
Okay, sir. Understand now.
Perfect. 24 over 7. Let's count. If your timetable good, you're going to know so this can go in a 24 3 times. And so 3 sevens is 21. So obviously to get to 24, you're going to need another extra 3. And then you're going to put it back over 7. And that is how you convert from an improper fraction back to a mix. All right? Everybody clear?
Yes, sir.
So for the mix to improper, we do that at the very beginning of the math problem. And from the improper to the mix, we do that at the very end of the problem, when you're going to produce your final result. Now that we have that concept then, we need to put it into action. But before we put it into action, I need to give you the steps that you need to follow. Because remember, maths one of them type of subject that will require lots of steps, you know. But sometimes even with the steps, I'm going to show you, students will, learn some topics later on down the line and then completely forget. So you need some notes as it relates to say, I can go back to my textbook, go back to my notebook and read Mr. Pierre Apex notes. And then I should be able to read the notes and be able to get myself back on track. So I want you to head up for me, addition and subtraction of fractions. That's where we're going to start. Addition and subtraction of fractions. In order to add or subtract. This is notes, guys, notes. In order to add or subtract, two or more fractions, in order to add or subtract two or more fractions, the following steps must be applied. The following steps must be applied. One, convert all mixed fractions to an improper. That's the first thing you have to do. Convert all mixed fractions to an improper. Two, find the lowest common multiple. That's step number two. Find the lowest common multiple. Lowest common multiple is abbreviated LCM. Step three. Divide the LCM. Divide the LCM by the denominators. Divide the LCM by the denominators. Hence, that is HENCE, hence multiply the result by the numerators. Hence, multiply the result by the numerators.
Sir, can you repeat rule number 3?
Number 3. Step
Yes,
3, you
sir.
said? Divide
Yes, sir.
the LCM by the denominators. Hence, multiply the result by the numerators. Step 4. Add or subtract where applicable. Add or subtract where applicable. And final step, write your answer in its lowest form. Write your answer in its lowest form. All right, so let's put it all together then. Because with a math problem that has 5 steps, it's always going to be up to the assumption that this problem is very difficult. When really and truly, I've just worded it in such a way that you can be able to go back and read these notes and be able to teach yourself or to bring yourself back up to speed. So when you give somebody a book and then say, oh, you know, I missed class last week, and then write off the notes, they should be able to read your notes and then look at a math problem involving fractions and be able to follow these steps as listed to get to their solution without even me being there. So let us put it all together then. Let's start off with something simple. Let us start off with a very simple problem such as 3 over 4 plus 1 over 3. Something like that. 3 over 4 plus 1 over 3. To simplify this problem, as simple as it may be, you find quite a few students who have either done fractions and for some reason them just not getting it, or them just kind of laid back and just think the fraction can work anyway. Working a fraction is not the same process as when you're adding a whole number. So for the students who in the future who might say 3 plus 1 is 4 and 4 plus 3 is 7, you can just prepare to get a bunch of incorrect markings for your paper, right? Fraction cannot be done like that. You cannot deal with a fraction as when you're dealing with a whole number. Hence why I gave you those steps earlier. So let us follow those steps. For this level of the math, step 1 is not applicable because there is no mixed fraction to convert. So we can ignore step 1 and jump right into step 2. Step 2 says we must find the lowest common multiple, which basically we draw one line and we try to find the lowest multiple, the lowest number that both 4 and 3 can go into without leaving a remainder. Now, some students might be able to just look at it and tell you that the answer is 12, while some students are still, them not so 100% when it comes to finding the LCM, right? Because we're teaching all different levels of people in this class. We're all being prepared for CSEC, but we're all trying to get our fundamentals, We want everybody to be on a level playing field. So the easiest way to find the lowest common multiple when you're adding or subtracting fractions is to pretty much multiply the numbers at the bottom. So then you just multiply 4 by 3 and you're going to always end up with a multiple. Most times, and I'm going to say, depending on the question, 95% of the time, you're always going to end up with the lowest common multiple. Further on down in the question, I'll show you an example where multiplying the two bottom numbers may not give you the lowest multiple, but it does give you a multiple. But let us stick with this for now. So 4 3s is 12. Step 3 says we should divide the LCM, which is 12, by the denominators, and when you get the answer for that, you're going to multiply it by the top. So the question is, how many 4s or how many groups of 4 can you get from 12? That would be 3. So you put the times 3 at the top here. And how many groups of 3 can you get from 12? That would be 4. You put the times 4 at the top here. All right, and then you proceed now to multiply to get the answers to go on top of the line. So we have 3 times 3 is 9, and we end up with 4 times 1 is 4. So now we end up here with 13 divided by 12. Because step 4 says we must add or subtract where applicable. In this case, because we're adding fractions, we are going to add because addition is what's applicable here. So 9 plus 4 is 13 over 12. Now the next question is, are we finished? Well, if you leave the answer right here, there are some instructors like myself that will give you the full marks, while you have some other instructors like myself who emphasizes on the fact that you should always write your answer to its lowest form. The lowest form of an improper fraction is a mixed fraction. So the question is, how many groups of 12 can we get from 13? You should end up with 1, and so the remainder is going to be 1 over 12. Both answers are acceptable, but we prefer, right across the board, we prefer our solution to be written in its lowest form, which is a mixed fraction. Is everybody clear?
Yes, sir.
Yes, sir.
Yes, sir.
No, nice. All right, so we now take it for granted that, oh, this is so easy. Let's do a subtraction then. No? So let's do something like 2/5 take away 1/3. So we're going to go through the steps again. All right. This is what I find right across the world. We don't want to leave it as a Jamaica thing. You know. Right across the world, students will find a challenge with this because they take it for granted. Okay. So here, math requires steps. If you miss out a step, you're going to have a problem. If you decide, I just want to memorize the math problem, all right, if you're a genius, then no problem. But if you're a student and you're trying to learn the math, like you're trying to learn it to the point where you cannot forget it, then you need to get the steps ingrained in your mind. Okay, so in this case, step 1 is to convert any and every mixed number to a improper fraction. Step 1 can be ignored because there is nothing to convert. So we go to step 2 and we draw one line and we say the LCM here is 5 times 3, which is 15. So put the 15 here. Now the question is, how many groups of 5 can we get from 15? I'm assuming that you guys will know that that's about 3. And how many groups of 3 can we get from 15? That's going to be an amount of 5. So we're going to proceed now to multiply the numerators by the result. 2 times 3 is 6. And 1 times 5 is 5. So we have a final solution here of 6 minus 5 is 1. And that's going to be 1/15. Now, unlike the first example, where we had to write our answer in a mixed number form, 1/15 is in its proper state. So because 15 cannot go into 1, we're just going to leave the answer as 1/15, because that is already to its lowest form. All right? Somebody's trying to get in, but after 8, so you're well late for the class. Who is this person? All right, I don't know what's going on there, but for the persons who are here, try and see. I know some of you guys are coming from work, so with that, I can make some exceptions. But for the persons who can log in, as soon as the host is able to let you in, try to log in to Zoom from about 6:45. So when I arrive, I can let you in by 7:10, because once I start teaching, it's kind of difficult to move from screen to screen to know when you want to come to the class. Okay, so come try see if you can log in early. All right, people. All right, boom. So we get that out of the way. So we have the basic idea of how to simplify a fraction. Everybody up to speed with me? Everybody's okay? Is there anybody who, for some reason, is lost? No? Yes? We're good?
Yes,
All
sir.
right. Everybody up to speed then. Not hearing, I'm not hearing any negative feedback, so that's good. All right, so we're on track then. Boom. Let us try to squeeze in. Let us not try to squeeze in. Let us now see an example where step 1 is now applicable. So you end up with something like 3 and 2/5. I'm going to do a plus again now. Plus 1 and 7/8. And you're asked to add those two fractions. Now, there is an archaic method that a lot of the older persons in this class may have been accustomed to. Way back in the 90s, they used to teach one like a method where they say you can add the whole numbers and then find the LCM of the fractions, right? I haven't seen nobody use that method in a while. So we just want to stick with just one method, which is always to get the mixed fractions to be written in its improper form. All right, so here we're going to take the 5, right? Let's change the ink here, guys. 1 second. Boom. All right, so we're going to take the bottom number, which is 5. We're going to multiply it by the 3, and then we're going to add the 2 to the result. Because we just run through a set of activities with that, right? So 5 3s is 15, and 15 plus 2 is going to give us 17, and that's going to be over 5, right? Plus, moving right along, we're going to take the 8 and multiply it by the 1, right? That's multiply. Oops. How am I multiply looks so? Multiply they look shaky. So may I work with that? All right. So 8 times 1 is 8, right? And then we're going to add 7 to the result, which is going to give us 15 over 8. And don't lose focus on the people. I don't want anybody to commit this very grave, unacceptable error of adding 17 to 15 and adding 5 to 8. Sir, I would never do that. But how some people do it, I don't know. They do it. They really do. But stay focused. We know, say, with fractions, once you add and subtract, you have to find what is known as your lowest common multiple. Yes? So your lowest common multiple can easily be attained by multiplying the two numbers at the bottom, which is 5 times 8, 5 and 8. So the product of 5 and 8 is 40. Now, 5 into 40 goes 8 times. So we're going to put that 8 at the top here. Whoops. Screen gone, guys. All right, ready again. So put that 8 at the top here, times 8. And then we have 8 into 40, run that by 5. All right? Boom. All right, so we're going to take out our calculators now because, you know, not all of us is going to get up and say our 8 times table or our 17 times table. So you use up your machine. 8 times 17, you guys should get 136. Confirm with me.
Yes, sir.
Yes, sir.
136, thank you. And then, hold on there, guys. All right, plus 5 times 15, that gives us 75.
Yes, sir.
So proceed now to go ahead and add where applicable. 136 plus 75. That should give us, that's 311. 211.
211.
211 all over 40. So we've completed step 1, 2, 3, and 4. Step 5 now, like I said, if you leave the answer as it is, being the instructor that I am, me I go take off half mark because I expect you to remember to always write your answer in its lowest form. But of course, me I go offer a little bit of leniency at first because, you know, you're new to all of this. So if you leave the answer as 211 over 40, I might, depending on the day, give you the full marks and then show you the remaining steps. Now, not everybody is able to get up and count by 40. Not everybody's going to get up and be like 40 plus 40 is 80 plus 40 is 120 plus 40 is, you know? We're not going to be able to do that.
Somebody said they were kicked out.
Somebody was saying that they got kicked out. Hold on. I'm not seeing the person in the room. So if they got kicked out, they're not here in the room waiting. I'm not seeing them, as you can see on screen here. They're not in the room. But all right. If they're in the room, they should message in the group and let me know. All right, so 211 divided by 40, right? Now, I want to show you guys how you can use your calculator to your advantage. Because, you know, we have a calculator, but I find that quite a lot of students, you know, they're not so equipped with the calculator. All right, so help me out now. You're going to go on your calculator, guys, and you're going to type 211 divided by 40. It's going to give you a decimal value. Now listen good, guys. Is when you see that decimal value, the only part of that number that you're interested in is the number that comes before the point. What are you seeing?
5.
Good. So what that is saying to us, what the calculator is trying to tell us is that 40 will go into 211 a little bit more than 5 times. Now, we need a remainder. Now, I heard 1, 2, I'm not sure if you guys are the type of student that thinks that the decimal place is the remainder. So let's say you get 5.37. Don't think that the remainder is 37. All right, you have people who think like that and believe it, right? However, if you want to find the remainder, what you're going to do is take your answer, which is 5, and multiply it back by 40. And it's going to give you 200. Now, if you're at 200 and you need to get to 211, that means you need 11 more spaces, not true? So 11 would be your remainder, and you're going to put that right back over 40. And this becomes your final answer. Is it clear?
Yes, sir.
So, all right, let us do one more, right? Let us do one more. Let me just go back to the first screen here and then just wipe off this here. So, big wipe. All right, wonderful. Okay, so now, let's do a subtraction, right? We're not rushing the process now, guys. So this is stage 1 of fractions. Once you have this fundamental, right, then we're going to do the fundamentals of multiplication, division on Thursday, which is our next class. And then what we're going to do now is put all of them together in one. So we see how to work out an actual exam or assessment structure type problem. All right. So watch this now. Subtraction now. Right. Same procedure, everything. 2 3/8 minus 1 1/4. Remember, I promised to show you an example where finding the LCM by multiplying the bottom numbers, right? Remember, I promised you that example. Here it is. Now, ready? We're going to go ahead and proceed. 8 times 2 is 16. Right? So we're going to times here, so, and then we're going to add the top. So 8 times 2 is 16. 16 plus 3 is 19 over 8 minus 4 times 1 is 4 plus 1 is 5 over 4. Not true? Now, so far in our examples that we have done, I've always shown you that multiplying the two bottom numbers will always give you an LCM, give you the lowest common multiple, right? But I did mention to you that there are going to be situations, for example, here, where when you multiply 8 by 4, you get 32. Now, 32 is a multiple, but it is not the lowest multiple. Then, sir, if it's not the lowest multiple, am I not going to get an incorrect answer? No, you're going to get the right answer. You're just going to give yourself a little bit more work. In fact, you're going to give yourself 4 times the amount of work. The values that you're going to get are going to be 4 times bigger than if you were to just simply look at 8 and 4 and recognize that the LCM is actually 8. Because since 8 can go into itself and 4 can go into 8, then it's only suitable enough here for you to just use 8. All right, I'm not going to do it both ways. I'm going to do it with the 32, and I'm also going to do it with the 8. Just so you see that it's the same process. All right? So, for the persons who are very knowledgeable to some extent about fractions, them are going to always know the LCM are 8. So, watch now. 8 into 8 goes 1 time. Times the top by 1. And 4 into 8 goes twice. Here. So we have 19 times 1 is 19. And then we have 5 times 2, which is 10. And so therefore, we end up with 9 over 8 as our final answer. That's all? Yes, 9 over 8. So boom, we get the answer. That's a 9 over 8, right? Easy, easy. But what if we have a student in the class who, them timetable no 100%, and them not really love maths like that. So them just one way or them can get the multiple. Easy, without having to think too hard. Let us say that we have a student here that says 8 times 4 is 32. Okay, no problem. Can we sort them out? 8 into 32. Let me just clear up here, so. Oops, Lord have mercy, that's too much. Big wipe. Small wipe. Boom. All right. So go back here, so now. This is for the student who multiplied 8 times 4. So 8 into 32, 4 times. And 4 into 32, 8 times. Look at the numbers that land on the line now. 4 times 19, that sounds like 76. So big the number they be compared to 19. And then we have 5 times 8 is 40. Look at 40 in comparison to 10. It's 4 times bigger. So 76 minus 40 is going to give us what? 36 over 32. And because this fraction is not in its lowest form, meaning say something can go into 36 and into 32. If you check it out, your timetable is up there, you'll realize that 4 into 36 goes 9 times. And 4 into 32 goes 8 times. You see, you still get the same answer. It's just that you're working a little bit hard. But like I said, 95% of the time, in fact, 99% of the time, when you get a math problem, it's always going to be a case where when you multiply the two bottom numbers, you always end up with the lowest common multiple. All right? But either ways, yes, there.
So we won't say now 8 into 1, 8 into 9. We won't do that.
Oh, yes, we never finished. Oh, yeah, thank you very much. We never
Okay.
finished. Thank you very much.
Yeah.
In my mind, guys, in my mind, I was thinking it was 8 over 9. You know? Tired, man. Let's go. Let's kick it. So now to wrap up the final answer now, we're going to say how much time 8 can go into 9? 1 time. And it's going to leave a remainder of 1 over 8. And you would have also done the same thing here. 1 and 1 over 8. All right? Is it clear?
Yes, sir. Yes, sir.
All right. So this is our introduction to fractions. So officially, we know how to add and subtract mixed fractions and fractions that are not mixed. This principle will be needed for our next class, which is on Thursday. But on Thursday, we're going to, of course, do a recap, and then we're going to dive into the concept of multiplication and division. And then, of course, the work that was sent in the WhatsApp group, we're going to use those questions to our advantage for a problem to be worked in the class. So make sure to have that at hand, because next class we're going to be working out all of those 5 questions together, okay?
Yes, sir. Yes, sir.
All right, let's have an episode. Leona, can you save the recording and can you send the recording